So here is our problem. A pitched ball is hit by a batter at a 45-degree angle and just clears a fence 98 meters away. Assume the height of the ball when hit is the same as the height of the fence. Find the velocity of the ball when it left the bat. Okay, so let's use given, find, and solve here. Let's write down what's given. Okay, here's the, and let's just make this is my level. This is a level where the ball is hit by the bat, and then over here it clears the fence. So it's just and it's 45-degree angle. So it goes up and comes back down to the same height. So what is delta y for the whole thing? Right away, you know delta y for the whole thing is 0. I might even write that down. Delta y equals 0 when you're right here. We know that this is 45 degrees. And we know that delta x equals 98 meters all the way across from here to here. That's quite a hit. And what we want to know is, what are we trying to find here? Find the velocity of the ball, v, or v naught. Okay, so let's solve this thing. Well, I know delta x, and I'm trying to find v naught. And well, the first thing I ought to do is take my velocity and break it up into its x component and y component. So we know that vx equals v naught cosine 45 degrees, and this is v naught sine 45 degrees. So, I mean, that's what this unit is all about, is about taking vectors and breaking them up into their x and y components, because they're in 2 dimensions. Now, I'm trying to find v naught. I know delta x, so let's take a look at that. Delta x equals v naught x times t. That is the only kinematic equation there is in the x direction. Now, what do I know? Well, I know delta x, and I know v naught x in terms of v naught, which is what I'm trying to find. So let's just write it like that. Here's 98 meters equals v naught cosine 45 degrees, and then time. Now look what we've got. We've got we've got v naught. That's what we want, but we also have time. So we have one equation with 2 unknowns. So what do I need? I need another equation with the same 2 unknowns in it. So what I'm going to do now is look in the y direction to get that. And so I know that for the whole flight, delta y equals 0. So I'm going to use the third kinematic equation. And you might see a pattern here. We're always using that third kinematic equation in the y direction. Delta y equals v naught y times t plus 1/2 a t squared. Well, delta y is 0, right? If you go the whole flight. So that allows me to cancel out that, and it allows me to solve for time. So time is equal to negative v naught y times 2 divided by a. We know what a is, right? Negative 9.8 meters per second squared. But what is v naught y? It's v naught sine theta. And let me put the 2 out in front, because that's just traditional. Divided by g. So now I can substitute this in for time up here. So let me do that. So I got 98 meters equals v naught cosine 45 degrees times t. But t is this large, ugly expression, negative 2 v naught sine theta, or sine 45 degrees. Let's go ahead and put the number in. Divided by divided by g, or actually let's go ahead and negative 9.8 meters per second squared. And I need that negative to cancel that. So let's take a look at this. I've got a V naught squared right here. So let's put that V naught squared. Am I still on screen? Yeah, I'm going to have to squeeze this in. Let me zoom out a little bit. So V naught squared, so this is kind of ugly, times 2 cosine 45 sine 45 divided by 9.8 meters per second squared. But now, and this is all equal to what? To 98 meters. So this is kind of an ugly problem, but I can take this now and divide, it onto the other side. So V naught is going to be equal to the square root of this ugly mess. 98 meters times 9.8 meters per second squared divided by 2 cosine 45 degrees sine 45 degrees. And actually, I don't need all that. That's not that bad. And that will be our initial velocity. V naught equals all of that. And when you plug that in to your calculator, and I'll leave it to you to do that, this is, and round it off, you should get 31 meters per second. Look at the units. You got meters squared per second squared. So when you take the square root, you get meters per second. That's good. So the units work, and that should be your answer right there. And so this is a difficult problem because you have to make a substitution, and you have to deal with some pretty clumsy algebra, but it's not too bad. Any questions? Yes. Where did I get the V naught squared? Good question. Well, see, when I substitute it in for time in here, see, I've got a V naught there, and I've got a V naught there. So it's V naught times V naught is V naught squared. Yes?
Then where did the 2 go?
Where did the 2 go? It's right here.
Oh, okay.
So it was right there, then it was right here, and then you had to divide, or you had to multiply both sides by this and divide both sides by this, and you get that. Any other questions? That is all.